So again, welcome to our Unit 4, Part 1 lectures. This is System Analysis and Design course. Today we are going to cover the use case diagram, and activity diagrams, and also functional modeling. Normally the use case diagram and activity diagrams is one of the UML diagrams, or the Unified Modeling Language diagrams, which consists of 14 different types of diagrams. And normally, this is the concept of object-oriented programming. When we want to design a system, and we normally use this diagram. For example, we have the class diagram, and there are so many diagrams. So today we will go through only these two. So that's our main objective. We should understand the process used to identify business processes and use cases. We may discuss what is a use case, also understand the process used to create a use case diagrams, and also the activity diagrams. And then we're going to do a comparison of the two. Also understand how to create them, how to create the use case descriptions, and how to create the functional models of a business process. So now we begin the process of turning requirement into functional models. What we mean here is that in a software development process, the first thing we do again is to analyze the system. And we should know what will be the input and what should be the output. So we get the system. We first have to know what the function of the system will be. So for example, I want to design a system to find the sum of two numbers. Then I know my input will be two numbers or two values. My output will be the sum of those two values. So the process of identifying these two major components, and that's the input and output, is what we call requirements analysis phase. So in the requirement analysis phase, we normally going to work with the users or the project sponsors, or basically anyone who is part of the project or have interest in the system. Then we're going to do our best to elicit all the possible functional requirement and non-functional requirement. So functional requirement will be what the system is going to do, the task of the system. The non-functional requirements will be based on the quality of the system. For example, is the system going to be user-friendly? Is the system going to focus more on security or speed and fastness of the system? So these are again the quality of the system. So we know models are normally logical. What we mean by logical is that they are independent of how they are implemented, whether manually or computerized. And so developing use cases from requirements is very, very essential in a software development process. So use case is how the system is going to interact with the environment. It's very important. So for example, if I want to develop a let's say inventory system, now the use case will be people are going to interact with the system. What features they are allowed or the privileges that will be given to them. And so this is the use cases. Example would be the store manager can update the inventory, but the store clerk cannot do that. The store clerk can count how many items are in the inventory, but they cannot update it or supply it. They only have to tell the manager. Then the manager may decide whether to order more or to whatever to do. So first thing is the use case. Use case, in this case, we are going to use a diagram to design it. Then the next step is to develop the activity diagram from the use cases. So activity diagrams will be the activities that the system will do in sequential order. First, we say the use case is how a system will interact with the environment. So by interacting with the environment, it's going to perform some task. So we have to identify all these use cases, more or less like a task. Then in the activity diagram, this is where we are going to lay down the tasks in order, in sequential order. What tasks to be performed first is very important. They have to be in order. This is normally used to illustrate the movement of objects between activities. So let's start with the use case diagram. These are some of the few elements that we need. It's very straightforward. For example, we may have the actor. The actor will be the user of the system. So we may have, let's say, a library system. We may have customers who can borrow or return books. We may have the librarian or the employees who can access and update the inventory of books that we have in the library or add more books. So the actors will be different types of actors. We can be customers, employees, managers, the president of the library. So this is actors or other interacting system. Also, the actors don't have to be I'm giving an example for only human beings, but an actor can even be an automated system. If we have an automated system that interacts with the system, then it's an actor. Then we're also going to have association. Association normally will be the lines that connect the actors and the use cases. So use cases will be like the task. So, or the process, major process. So here, for example, we have the use case, interaction, inclusion, extension, generalization. And also a major process in the system is called, again, the use case. Also, we may have a boundary of the system, like a subject boundary. This will be a name box that shows the scope of the system. So if I have a library system, then maybe the boundary will be within a process that we can borrow books, or we can accept books, or we can order for books. But maybe in the library, we don't sell books. So that will be the boundary that we can sell a book. So again, the use case diagram, we have the actors, who are the users. It can be a person or automated system. Association will be the lines that connect the actors and the use case. And normally the use case will be the major task or process in the system. Then association also can be interaction, extensions, inclusions, and generalization. Then we have the boundary or the subject boundary. Here is a name box that shows the scope of the system. So identify a major use case is very important when we are developing a new system, because the use case, again, is the process, what the system will do. So in the analysis phase, we're able to identify the functional requirements, which are the tasks that the system will do. Most of the time, this functional requirement becomes the use cases in the design phase. Now we are in the design phase now. We get the list of requirements from analysis phase. Now we are going to design. So the design, the UML diagrams is like a design tools to create models. I can create the class diagram, use case diagram, activity diagram, sequential diagram, etc. So here, the identify major use case, they give us some basic rules here. First, we have to review the requirement definition, which is very important because the requirements where we have all the functional and non-functional requirements. Also identify the boundary, the subject boundary. If this system is for a library, most likely we can't sell books. A library is not a bookstore. Also, we should identify the primary actors. The library may need customers who can come and borrow or return books. We need employees that works there, and that's it. And borrowing book, you have to be a human being. An automated system like a robot or botnet system program cannot borrow a book. I cannot write a code to borrow a book through the library system. So these are all again going to be the boundary, and also identify the actors. Also, we need to identify the business process and the major use cases. This is very important. Use cases is what the system is going to do. Business process, again, every business organization have operational way. You go to a bank, business operations in a bank or processes are different from if you go to a library or supermarket. So we have to identify all this. Then carefully, we're going to review the current set of use cases. We can split or combine some to create a right size, or we can identify additional use cases also. So creating a use case diagram, we're going to place and draw the use cases. The use cases normally will be inside the boundary, the subject boundary, which is a box. Then place and draw the actors. Actors most of the time will be outside the box. Then draw the subject boundary, then add the association, which will be the line between the actors and the use cases. And that's a nice example here. This is our library circulation system. So our boundary is the box we can see. So we can see that all the use cases, this is the over sign, these are all the use cases. They are inside the box, the subject boundary. And the actors are outside. Then we have association between the use case and the actors. So here you can see we have two different actors. We have the librarian, then we also have the borrower. The borrower is the actor down, the librarian is the actor at the top. Then we can see the use case for the librarian. For example, the librarian can process overdue books. It can also maintain the book collection. But a borrower can only borrow books or search for the collection so that he can borrow. And also when the book is due, you have to return the books. So borrow books, we may need a personnel office, or registrar office, maybe register with the library system. So this is a very simple example of a use case diagram. Always we should have the boundary. In the boundary, which is the box, that's where all the use cases will be. Use case again are the task or the function that is. So here we can see a use case, borrow book is a task. We even identified this in the requirement phase. If I'm going to design a system, a library circulation system, in the requirement phase, surely I have to identify that will even be a functional requirement, the major requirement. Returning book, borrow book, check for book, or update collections for the managers or the librarian. So again, this is our use case. Now next we move to activity diagram. So this is the BPM stand for business process management. So business process management with activity diagram. Here we say a business process consists of a number of activities. An activity diagram normally shows the sequence of these activities. That's what we mentioned earlier. Activity diagram normally consists of activities that the system will do, but they have to be in sequential order. So diagrams are abstract. They are not detailed. Abstract. Yeah, we just, if the activity of a borrow book, then borrow book. I don't want to go detail about borrow book. You have to have an ID card. You have to register for the library. You have to be over 18 years. So this is going detail now. But at an abstract level, we say borrow book, that's enough. So they also model the behavior independent of objects, and they can be used for any type of process. So these are the symbols for activity diagram, which is also, as usual, like the use case diagram, it has its own symbols. Activity diagram also have its own symbols. So we have the action or activity. We can see how the symbol look. This will represent an action or set of actions. Then control flow is a line, but the line you have to show the arrow. That's why it's called control flow. And it's to show the direction where it's heading to. Then we have an initial node. This symbol means the beginning of a set of actions. So when we are starting an action, we start with the initial node. Then the final node means stop all flows in the activity. Then we have the diamond, which is almost like the data flow diagram. A diamond node is where we make a decision. So if it's true, go right. If it's false, go left. Or continue from down if it doesn't matter true or false. So this is called the decision node. Is always the diamond shape. So the element of an activity diagram, first is the actions and also the activities. Here we say something performed for specific business reason. Example given here, get patients information. It's an activity. Or borrow book, return book, update the library system. These are all activities. Now, the object nodes normally will represent the flow of information. We saw the symbol in the earlier slide. So object node will represent the flow of information from one activity to another. Then we saw the control flows, which model the execution path. Then object flows also model the flow of objects. Then the control node, we have 7 different types. So control node, we have the initial node. Actually, we talk about the initial node as for the beginning of the set of activity or actions. We also have the final activity node. We stop all the actions and activities. We also have a final flow node. This also will stop one execution path, but allow others to continue, which is the final flow node. Then decision node, to test a condition and make a decision. So a test to determine which path to use to continue. Then merge node means we rejoin mutually exclusive execution path. Then we have the fork node. This will separate a single execution path into one or more parallel paths. Join node normally will rejoin parallel execution path. And these are the symbol representation. So we have an action, we have activity, we have the class name, association, which is the control flow, etc. till the end. Now let's see the example. This is a sample of activity diagram. So you can see the beginning. We have get patient information, which is again activity. So in order to get patient information, here we said we should appoint request, apply request info. So getting patient information, I may need some information about the patient, and I should get it. Now we go through if we have an old patient, so now we have a decision. This is our decision node. So if I'm coming and it's a new patient, I'll go through the left. Old patient, I'll go through the right. Sorry, old patient, I'll go through the left, and new patient, I'll go through the right. So if I'm new patient, I'll go through the right, then I need to create a new patient file in the system. Then make payment arrangement. What is the register fee? Then create the appointment. So in a new patient, we create a new patient file. We make payment arrangement. Then we create appointment. Now, if it's an existing patient, we don't need to create a new folder. So which means the first thing we do is to update the patient information if the information given to us, some of them are new. Then also we make payment arrangement. And then next, if we about the appointment, we can create appointment, cancel appointment, or change appointment. So you can see that this is in sequential order. I create a new patient, make the payment arrangement before I create the appointment. The lists have to be in sequential order. The same thing applies to old patients. So we have something we call the swim lanes. And swim lanes also, we can see the diagram. is the line or control, more or less like control flow, the arrow. So normally we use it to assign the responsibility to objects or individual who actually perform the activity. And it represents a separation of a row among objects. And this can be drawn as here we have vertical line, but also it can be horizontal line. Like here we have horizontal. So the guidelines for activity diagram, we always need to set the scope of the activity being model. So we have to say, we know what is a scope creep when we go beyond the features that we have, or we keep adding more features to a system that has been already designed. So we have to set the boundary of the activities that can be the system will be doing. Identify all the activities, connect them with flows, then identify any decision that must be made, identify potential parallelism in the process, which means two tasks can be performed at the same time, very important. Then we draw the activity diagram. So next, creating activity diagram. Yeah, they say we should choose the business process identified previously. The business process modeling will be made from requirements, list of requirements. So we need to again review the requirement definition and use case diagram. Then review other documentation collected, identify the set of activity used in the business process, identify the control flows and nodes, also identify the object flows and node. Then we have to lay out then draw the diagram. So what is a use case, as we said earlier, is the primary driver for all the UML diagram. Why? Because use case is the task, is the main process of the system. And also it shows the activity performed by users, because again, it's the process. Also, it describes the basic function of the system, what the user can do, how the user responds. So use cases are very important. It's more or less like the functional requirements, but this is a design phase. So use cases are building blocks for continual design activities. Each use case describes one and only one function. So use case again is a function, and it's only one function at a time. So we have different types of use cases based on the amount of information we have, and also the purpose of the use case, the system. So we have, for example, essential and overview. We have high-level overview of it as issues essential to understanding the requirement or required functionality. Now, rare and overview means high-level overview of a specific set of steps performed on the rare system once implemented. Then we also have the detail section, which is detailed description of issues essential to understanding the required functionality, which is detail and essential. And the rare and detail is detailed description of a system set of steps performed on the rare system once implemented. So description of a specific set of steps performed on the rare system once implemented. And we talk about the element of use case description. Overview, we can have the name, the ID, type, primary actor, brief description, importance. These are all names that we can give to the system. Relationship can be association, which is communication between the use case and the actor. It's called association. We can also have extend relationship, which normally will extend the functionality of the use case. Then we can include another use case, which is include. Or generalization means allow use case to support inheritance. And flow of events, we can have a normal flow, subflow, alternate or exceptional flows. So alternate or exceptional flows are those not considered the norm. And then sub means break it down. So subflow means decomposed normal flow to simplify the use case. So use case writing guideline. First, write the form of subject, verb, direct object. So we know from the verb, we can get an action, the activity. Make sure it is clear who the initiator of the step is. Now we should write from independent observer's perspective, write at about the same level of abstraction, and show the use case as a sensible set of steps, and apply the case principle liberally. Write repeat instructions after a set of steps to be repeated. Now, creating the use case description, we need to pick a high priority use case and create an overview. So this will be like example, list the primary actor. We should determine its type. List all the stakeholders and their interests. We should determine the level of importance. And briefly describe the use case, list what triggers the use case, and list its relationship to other use cases. This is very important. Then fill in the steps of a normal flow of events required to complete the use case. We also ensure that the steps listed are not too complicated or long. We should make it as simple as possible, and they should be consistent in terms of size with other steps. We should also identify and write the alternate or exceptional flows. Carefully review the use case description, confirm that it is correct. And we also have to iterate, go through over the entire set of steps again. Make sure everything is correct and cross-check. So that's where we come to verifying and validating a use case. And we always have to validate, make sure it's correct, and verify it. So use case must be verified and validated before beginning structural and behavior modeling. Then we should utilize a walkthrough. A walkthrough means we can perform a review of the model and the diagram created so far. We also need to perform by individual from development team and client, facilitator, presenter, recorder. Recorder can create a transcript or scribe to take notes, especially to and so that's the rules. And this will be the summary of what we covered today. In this lecture, we cover what is a use case diagram and also activity diagram, how to construct a use case diagram, what they are made of, the same thing, how to construct activity diagram and how they are made. So again, wish everybody the best, and you can either subscribe, like, or comment. Thank you.